Good evening, everybody. We're almost done with the class. We're on day 28. We're going to start talking about the sample final exam. We've covered all the material that we're going to cover in the class, but we are going to spend a while getting ready for the final. So one of the best ways to study for the final is the sample final. It covers everything that we've covered so far, chapters 1 through 11. Okay. Sample final exam is going to start on page 605 in your course pack. It's pretty big. It's 14 pages long. We're not going to get through all of it today. That would be crazy. That would be nuts. We're going to get through some of it today. Cindy and Elaine will cover some of it on Monday. I'll cover the rest of it on Tuesday, the 28th. So we are going to cover the whole thing. Um, but I don't know if you want to grab the whole thing out just so you don't have part of it is here and part of it is still in the folder. So anyway, we'll get as far as we can today. Um, so for the sample final, it's not due next week on Tuesday. It is due on April 30th. And if you need to turn it in May 1st, I'm fine with that, but May 1st is the last chance to turn anything in for the class. Okay. So it's not actually listed under today, it's listed under day 29. So here is the sample final exam in Canvas. If you click on that in Canvas, there's two links here. One link will take you to our data sets for all of our worksheets, and this is the last one. So at the very end is a link for StatCrunch, and I'll drop this in the chat for you so you don't have to go find it. Um, and there is that in the chat. Um, and there's a second link, which if you click on it, it takes you to a picture of a Galapagos tortoise. I don't know why. Maybe we'll find out. So, so there you go. That's what they look like. They're uh, they're endangered. So, right. So, okay. Um, anyway, going back to what we were talking about a second ago. So, if you are, this is the last day of the discussion boards. So, if you need to fill out the discussion board because you missed today and you are watching this on the recording, there's no discussion board for next week. So, you do not have to come to Zoom next week. I mean, we're covering the sample final, so you probably want to come if you can. And if you take the final exam at the testing center, you don't have to go to the Zoom um, for that. So, um, okay. So, um, what else did I have? What else did we need to talk about? I think that's it. Um, so, for the sample final exam, um, as I mentioned, it's one of the best ways to study for the test because it covers everything. Okay. If you have if you have a chance, try working on the sample final exam on your own. Okay. Um, it's not going to take that long. So there's no lecture notes, right? So today and next week, you don't have to do any lecture notes. So spend that time that you would have been doing the lecture notes, try doing the sample final on your own, and then bring it to class. And when Cindy and I go over the questions, you can say, yep, I got that right. I got that right. Or if you didn't get it right, you can erase it and write down what it should be. Okay. And then you'll know, oh, I got that wrong. I need to study that some more. Okay. Or if you try the sample final on your own and you get stuck on something, again, you'll know which questions you need to study and, we'll still be able to give you the answers in class. Okay. So we're not going to cover the whole thing today. We'll go through 5 pages, but that means there's still 9 more pages that I would love for you to try on your own this weekend and see how it goes. Okay. So, um, all right. Anyway, let's jump in to page 605. Now, um, unlike other worksheets where I go through and I give you hints, we've learned all this material, so you guys know all this stuff now. So I'm going to ask you guys to help me out with filling this out. Um, and I'm also going to record the whole thing. So for those of you who are watching it on the Zoom, you get all the answers, okay? Because like I said, if if you are watching on Zoom, pause right here. Don't watch this part yet. Go try it on your own and try seeing if you get the right answer, and then come back and watch the recording, and you can say, "Yep, I got that right." Oh, I didn't get that right. Because, if you're just copying my answers, like, okay, yeah, you're going to get 100%, but that's not the point. The point is, are you going to be ready for the final where there's not hints and there's not me telling you, here's how you do this, okay? So, anyway, question number one, the following box plot shows the percentage of a state's residents who are Hispanic. Question A, what was the shape of the distribution for the South region? Um, so the South region has a big skew to it has a big line on the left and a big box on the left. So I've got two people say skew left, two people say skew right. Um, so it's got some skew left because of this line and this box. But it also has two outliers off to the right. So yeah, this is a terrible example. If we'd been asked for the West region, that would definitely be skewed right. The Northeast region would definitely be skewed left. So, but yeah, um, there are two outliers out here. Um, this is a terrible question. So, hopefully you won't see something dumb like that on the test on test day because I wrote it and I've used the test before, so I made sure to don't have any issues with it. So I'm going to go with skewed left just because of this line here and this box here. But you are correct. There are outliers up here. Hopefully the next question's better. Um, Based on your answer from part A, so whether you say it's skewed left or skewed right, if it is skewed, which measures of center and spread should we use? Now, if you said symmetric, we would say mean and standard deviation. Okay. We haven't talked about median and interquartile range in a long time, since before the midterm, right? After the midterm, we started talking about mean and standard deviation. That's all we talked about. Okay. And the reason for that is because the central limit theorem that we learned about in chapter 8 says that if your sample size is big enough, then the sampling distribution looks like a normal curve, which is symmetric. And so you can use mean and standard deviation. Okay. So, but if your population is skewed and you're not doing a sample, you're doing the whole thing. So if I was measuring like home prices and I had the entire population, I would want to use median and interquartile range. Which region had the largest average? Now, we don't actually know the mean here, so we'll use median in this case. Yvette says the Northeast. So uh, Gabby says the West. Largest average. So the median is the middle line right here. And whichever of these lines is farthest to the right, that's the one that's the biggest. So it looks to me like the West is just a tiny bit farther to the right than the Northeast. I'm gonna go with West. Yeah. Which region had the smallest range? Measuring from the minimum to the maximum. Now, if these outliers weren't here, it would be the south, but um, the maximum is actually this point right here. So the range is from here to here. So which one had the smallest range, though? Gabby says Midwest. Crystal agrees. Yeah, Midwest. Good. Which region had the largest spread? Now, in this case, we're measuring interquartile range. That's the width of the blue box. Okay. So we're not looking at the whole range. We said the Midwest is the whole range. Which one has the largest blue box? That would be West. That's the largest interquartile range. Yep. You guys got it. 50% of Northeast states had a Hispanic percentage above what? So it's this middle line right here. If I drop that middle line down here, it's between 10 and 15. Looks to me like it's maybe a little closer to 10. I'd accept 12.5. I'm going to put 12%. I agree with you, Yvette. I don't think it's 13. I think that this line, if I drop this line down here, I think it's closer to 10 than it is to 15. I would take 12.5 though. What percent of Western states had Hispanic percentages below 28.7%? You guys got it. So 28 is right around in here, 28.7. So that lines up with this edge of the blue box, which is the third quartile. Third quartile is 75% of your data is below that. 75%. Good. Florida has the second highest Hispanic percentage at what? So the highest dot for the South would be this one, but they said second highest. So what's the value for this dot? This one's Florida right here. 26.5. Yeah, I'm good with that. 26, 27. Yeah, put 26. Oh, I got 2 votes for 26.5. All right, we'll go with that. All right. Yeah, you guys got this.
I have a question, Joe, before you move on. Um,
Oh,
so
sure.
did so did it matter if we picked skew left or skew right for the first one?
No, this is a terrible question. What would you pick for that one, Cindy? Question 1A.
I don't know. That like I
So it has some skew leftness because of this line and this box being
yeah, I
bigger
would
on the
probably
left,
say,
but it has
but
some
it's
skew
got all those
rightness
outliers
because of
pulling
the
it to the right
outliers.
though.
Hmm.
I don't know.
So
I would probably say
would you
right.
pick symmetric? Yeah, it could be symmetric too. Anyway,
I think
we
that
go.
the outliers are supposed to pull it, so I think
Hmm.
technically it should be skewed right, but
Skewed
I
right.
don't know.
Okay. So, um, the answer in this case is you can pick any of them. I'm not going to mark you off. So you get a free bonus point. Good job, everybody. But yeah, on test day it'll be a little more obvious. Also, we've seen before that skew left and skew right are not the only way. Looking at the box plot is not the only way to tell if something is skew left and skew right. You could also look at a histogram, and you could also look at the mean and the median. So if I actually had this situation and I was trying to figure it out, I would want to look at the mean and the median because these dots are going to pull your mean to the right, and these lines here are going to, this line and box are going to pull your mean back to the left. And it's quite possible that your mean lands very close to your median, in which case I would probably call it symmetric. Anyway, regardless, I'm not going to mark you off for that one. Put whatever you like. Um, right. So page 606. A country's gross domestic product, GDP, is an economic measure of how much stuff the country produces. Okay. The carbon dioxide is a greenhouse gas that contributes to climate change, often produced by humans. Scatter plot shows the relationship between the GDP and the CO2 emissions for a random sample of countries. All right. So they've done the stat crunch for us. Which variable is the explanatory variable? Yes, see if that's got it. GDP, so explanatory is the X. The X-axis is GDP, right? Which variable is the response variable? CO2. Yep, emissions. Good. Is it two S's on? No, it's there you go. We're good. Emissions. Okay, great. How many countries were sampled? Sample size 47. Yes, you guys got it. What is the strength of the linear relationship between the two variables? I says strong positive. James says moderate positive. I need a tie break. Strong positive says Mike. What page would I find? Oh, now I've got Mike. Your tie got unbroken. Gabby and Yvette say moderate positive. What page do I find the number line for the correlation coefficient? Yeah, page 255 for this. There is a number line that says if you're looking at the correlation coefficient, not the R squared, not the coefficient of determination, we need the R. Okay, so correlation coefficient is 0.85, which is just above 0.8. So it is strong positive. Okay. Which makes sense, right? If a country makes more stuff, they produce more things, then they're going to put more CO2 into the atmosphere, right? You have more factories, more people, uh, more tractors producing food, right? All right. Interpret the coefficient of determination. So now determination, now we're looking at the R squared. Coefficient of determination in the context of the situation. That is also on page 255. There's a script for it. We need to write this as a percent. What would R squared be as a percent, please? I think it says 72.9%. Yeah. Doesn't say how many decimals to have, so that's totally fine. 72.9. I would take 73. I would take 72.9 to, but don't write the whole thing out. 72.9% of the total variation in CO2 emissions is explained by the least squares regression. 72.9% of the total variation in CO2 emissions is explained by the least squares regression line. All right. All right, the regression equation. So it's right here. I'm not going to write it with CO2 and GDP. I'm going to write it with X and Y. So technically this is Y hat. Okay. You don't have to put the hat on it if you don't want to, but we've seen before that like P hat is not P. P hat is an approximation for P. P hat is the probability when we're looking at a sample, right? We take our sample, measure the proportion, and we say, okay, well, that's probably close to the population proportion. Same thing here. This is not actually Y, it's Y hat. You're not actually measuring the true value of the height of the dot. You're measuring where the dot would land if it was on the line. Okay. It's a minor detail. You don't have to put that on there. It's just there to remind us that yeah, it's approximate. You can write this in either order. You can write it as 211 plus 0.496x, or you can switch them around. I like to write it this way, but just keep the x attached to the 0.496. What is the slope? So one of these numbers, either the 496 or the 211, one of them is the slope. Which one? Has got it. 0.496. It's the number attached to the x, okay? So whichever number is attached to the x, that is your slope. Interpret the slope. So that's in the middle on page 255. It goes, if x, which is GDP, increases by one unit, one x unit, one what is the unit here? $1? Almost. It's not, there's a little more to it. What's the unit here for X? Kiwi says percent. Mike says it's dollars per person. So right here, it says that the units are dollars per person. It also says it in the per person. Also says it in uh the paragraph here. Yep, $1 per person. So GDP increases by $1 per person. Then Y, which is CO2 emissions, is expected to increase or decrease. Yep. Right, it says increase because it's a positive slope and a positive correlation coefficient. By is expected to increase by approximately or about, out of room, so 0.496, and then we need to write what the Y units are. Y units here are pounds per person. Pounds per person. If GDP increases by $1 per person, and CO2 emissions is expected to increase by approximately 0.496 pounds per person. That makes sense, right? Because if GDP increases by $1 per person, so every person in the country makes $1 more worth of stuff. So each farmer produces one more apple. Each, person working at the M&M store or M&M factory produces one more bag of M&Ms. I think they're more than $1 now. Anyway, each person is going to produce an additional half a pound per CO2. Okay. What is the y-intercept? It is 211.447. Explain why this does not make sense in the context of the situation. Impossible for what? Impossible for So if you're on the right track, it's impossible for GDP to be zero. But I need to know so what are the dots? Correct. Each dot here is a country. So it's impossible for a country to have a GDP of $0. Okay. Why does that matter? So it is possible for a person to have a GDP of zero because, like, a baby, like they're not producing nothing. Okay. Um, someone, so, but it's impossible for a whole country to have a GDP of zero. That means that every single person in that country has to be sitting around lazy, doing nothing. Okay. That's can't happen. So, all right. For the US, X is 61,400, right? Find Y for the US using the regression equation. Explain what the values mean in the context and units. All right, so Y hat equals 0.496 times our X plus 211.447. Who's on calculator duty today? What did I give you? One day I will have a GDP of zero. Sitting around doing nothing. All right. 3,029 0.447. No, I mean when I retired. Like, I don't mean right now. All right. Uh, explain what the values mean using context and units. The US has GDP of $61,400 per person. So each person in the US makes $61,000 worth of stuff each year, right? Per person, and uh CO2 emissions of approximately or about. Oh, Mike says he got 30,000, different number. Well, let's just see here. 0.496 times 61,400 plus 2. Yeah, I got a different number too. All right, let's change that real quick. 3,665.847. Okay. Gabby says she agrees. All right, good. 30,665.847 pounds per person. All right, let's read this and make sure it makes sense. The US has a GDP of $61,400 per person. Okay. And CO2 emissions of about 30,000 pounds per person. So each year, every person in the US produces $61,000 worth of stuff, and around 30,000 pounds of CO2. They put that much into the atmosphere. That's crazy, right? Now, this 61,000, this is not what you get paid, right? Uh, you don't get paid equal to the amount of stuff you do. You get paid less than that, right? So because like when you work for a company, you make the company $61,000 worth of stuff. They pay you like 50,000 and they get a profit, right? I mean, that's how work works. So anyway, if they paid you more than you produced, then they'd be losing money. All right. Following table shows a probability distribution of a random sample of diabetes patients in the US in 2020 by gender and race. According to the CDC, note that AIAN means American Indian or Alaskan Native. Okay, interesting. What is N? 1,887. That's the number we need the context to. If that says that it is diabetes patients, yes, it's not just 1,887 US adults. It's a specific group here. Random sample of diabetes patients. Good. All right. For a single person, black and female, are those disjoint, not disjoint? We'll start with that. This should be two problems in one, but anyway. Disjoint or not? Yeah, James and Raya say it's not disjoint. Correct, yes. Um, so yeah, on the final, I made sure to split these up so that it's, two questions and it's not asking both at the same time, but technically these are dependent. Okay. Um, for two random unrelated patients, AIAN for the first patient and AIAN for the second patient, those are disjoint or not? So if the first patient is American Indian, can the second patient also be an American Indian? Yes. These are not disjoint. Are they independent or not independent or dependent? Yeah, it's not disjoint. Independent or dependent? Independent, that's correct. Yep. Mariah says they're independent, yes. Okay. Yeah, different people, yeah. Choosing one random patient, find the probability that the patient was Hispanic. So probability of success is over total. Our total here is 1887. What number do I put in the numerator here? Oh, are we circling both? No, you only have to circle one. Um, but if you're studying off of this, it might be helpful to have both. Crystal says that Hispanic is 426, correct? And if you divide those, so Yvette did it for us, 0.2258. Thank you. What is the probability that the patient is not black? So that is 1 minus probability that they are black, which would be 1 minus, what's the black number, the numerator here? How many people in the study were black? 447. Thank you, Raya. And if we put that in the calculator, that says that that is 0.7631. Okay. What is the probability that patient is Asian and male? What number do I put in my numerator here? How many were Asian and male? So male row is this one. Asian column is this one. That's not Asian. That one's American Indian. 162. Yes. Right there. And that says that that is 0.0859. Now, for this one, white or female, that's going to depend on whether those are disjoint or not. What page is all of these, are all these probability rules? Does anyone remember? Page 254 at the bottom. Yes, 254. If they're disjoint, you just add the two together. If they're not, you add the two together and subtract when it's an and. So white or female, are white and female disjoint or not disjoint? They are not. Yep, that is correct. Yeah, that's got it. Yeah. So we need to use this rule here. Okay. So first we'll do the probability of white, probability of female, probability minus probability of white and female. All right. So white is 258. Female is 921 plus 921 minus what number is the white females? 112 right here. Yes. All right. Put that in your calculator. To put this in the calculator, do we need parentheses or not? Mike says no and yes. Yeah, yes. Need parentheses around the numerator. Yep. If you're going to type it in like this, yep. If you want to write it as three separate fractions, you can. It's just a lot more typing. Yeah, type the number 1887 three times. Do that. What do we get from the calculator when we put this in? Yeah, we got 1 million. make sure you put parentheses around the top and bottom. We're looking for a probability. Remember, probability is between 0 and 1. So make sure you put parentheses around the numerator. There we go. 0.565. There we go. Yep. That's why I was asking, should we put parentheses around the top or not? Yes, we do want them. All right. For parts H and I and J, this is a typo. Whoops, sorry about that. We're going to choose 3 unrelated random patients. That means that they're independent, okay? Find the probability that all are Hispanic. On page 254, it says that if you're looking at multiple independent events, you want to find the probability that the first guy is Hispanic and the second person and the third person. What you'll do is you'll just do you'll multiply probability of a Hispanic times probability of Hispanic times probability of Hispanic, okay? So in other words, we have 426 is the Hispanic one. 1887 is the total. And we'll just multiply that times itself 3 times. Times 426 over 1887 times 426 1887. Okay. Or if you didn't want to do all that, you could do 426 over 1887, put it in parentheses, and cube it. Okay. Um, so I would do it this way. See. And actually, we calculated the probability of Hispanic earlier, so you could just cube this if you wanted to. 0 point what? Zero point 0.0510. That doesn't ring a bell with this morning. Yeah, I think Gabby's got it. Yep, Yvette agrees. 0.0115. Oh, yeah, yeah. You just put it as a 3 instead of a 2, yeah. Okay. Uh, 3 unrelated random patients. Find the probability that none are black. Okay. So we've already done not black earlier. 0.7631. And if we cube that, that will give us probability that all 3 are not black. 0.444. Sound like you made that up, Mike. Nope, Gabby agrees. 44444. Yeah, good. Okay. 3 unrelated random patients. Find the probability that at least one is Asian. So that is going to be at the bottom of page 254. At least one Asian in 3 tries is this formula. 1 minus probability of not Asian, and then, all right, so probability of at least one Asian.
Hey Joe, I put 0.444 because I thought we were only doing three decimals, but if we're doing
Two,
some
two
of
of
them
them are
are
four.
four. Oh, okay,
No,
got
no,
it.
all of them are four. Oh, did we miss a decimal on this one?
Yeah,
We did.
that yeah.
Um, yeah, we missed a four. Sorry. There we go. Um, on test day, I am often not going to be grading your answer. If I can see that, if you put in 0.565 as your answer, I can tell that you knew what you were doing. Okay. This is not a rounding class. Yes, we do a lot of rounding. And that's because in statistics, we have a lot of decimals and a lot of decimals that go on forever. Okay. Um, Not only that, but statistics is one of the most real world used math you know classes or math topics. So you've seen before where there's times where we do like a math problem and it's not actually about a real world situation, but almost all of our problems are about real world situations, and real world is messy and has rounding. So at any rate, again, I'm not grading your answer, I'm grading your understanding. So sorry if I missed that four there. Um, Probability of at least one Asian in three people is one minus probability of not Asian, and then you cube that. Okay. So this is kind of like two problems in one. We're going to pause here and come over here and calculate probability of not Asian, which is one minus the probability that they are Asian. Asian is 287. So can somebody do this in the calculator real fast for me? 1 minus 287 over 1887. Point 8479. Okay. So that is not our answer. That is the probability of not Asian. We need to put that right here. So it's 1 minus 0.8479 cubed. Our final answer is 0.3904. Okay. That's our answer. As we're going through these, by the way, through the sample final, I've been asking like, how do I do this one? What's the answer here? And people have been jumping in on the chat, and you guys have been doing great. But if I ask a question and you're like, I'm not sure, I'm gonna wait and see if have someone else answer. If that happens, put a star next to it so that you know that like it wasn't immediately clear for me how I would solve that, and I need to study that. Okay. So if we were doing this one, you're like, I'm gonna wait and watch Joe do it. Just put a star next to it so that you know, okay, when I come back and start studying this, I need to, you know, make sure I pay attention to this, maybe try some of these on my own, maybe go back and look at uh, you know, how this was done. Okay. Write some of these on my 8.5 by 11 piece of paper. Okay. Or if you had a chance to try the sample final on your own and you find that one of the questions you got wrong, erase that and write down the correct answer, obviously, for when you turn it in, but put a star here so that you remember, okay, I got that wrong, so I need to study that a little more, okay? Which probabilities above are unusual? You guys got it, just H. Less than 5%. Yep. These probabilities above, are they classical, empirical, or subjective? So, subjective is if you just have a gut feeling on it. Classical and empirical, so it can be confusing, which one's which. Um, Classical is where we are talking about it and talking about what could happen in this game or this experiment, but we haven't actually done anything, okay? We haven't actually rolled the dice yet. This is based on a real study. We've actually went and counted people, and this is an empirical one. Yep. Gabby got it. So again, if you got that wrong, just put a star next to it and go and just, all right, I need to go back and make sure I understand those, right? All right. Page 608, number 4, following probability distribution shows the number of animal shelters in a random country in Michigan in a random county, random country, random counties in Michigan, 2022. Explain what must be true in order to verify that this is a valid probability distribution. Do you guys want me to write it in math or write it in words? Gabby wants words. Mike wants math. All right, well, here's the math. Probability of X is if you add up the probabilities, you get 1, and all of the probabilities are between 0 and 1. So sum of probabilities is 1, and or you could say, and then probabilities all between 0 and either of those is fine. Find the mean and the standard deviation of the probability distribution. So how would I do that? StatCrunch. Yes, Mike says StatCrunch. All right. So what buttons do I need to click in StatCrunch? So if I come over here to StatCrunch, it is in here already. And on test day, there will be a link that you can click on, or if you are taking it at the testing center, you'll just type that into your browser and you'll be able to get to the data sets in StatCrunch. So we have it here. This is the number of animal shelters in each county and the probabilities. But what do I click on in StatCrunch? Because we've clicked on a lot of things, right? So we've done stat calculators and stat t-stats and stat regression. So it's probably stat. You probably click on stat something. Or if you're not sure what buttons, because you don't have it memorized, and I don't expect you to have it memorized, we have our exam notes packet. What page in the exam notes packet? Because that has all the StatCrunch clicking steps, a lot of them, right? So what page am I looking at though? Page 254, maybe. Yes, Crystal, you got it. Page 254 is finding means and standard deviations. There's 3 methods here. We have raw data, which is stat summary stats columns. We have frequency distribution, stat summary stats group bind, and probability distribution stat calculators custom. So Mike says it's method 1 Jalen says it's method 2. Is it method 1, 2, or 3? Page 254. James says it's 3. This says it's 2. So method 1 is if you have a raw data, you have a single column or single row. Okay. I don't have one row, so it's not method 1. Frequency distribution is if I have a table with whole numbers for frequencies. I do have whole numbers here, but these are not my frequencies. These are probabilities. I have a discrete probability distribution. And I know that because it says right here, following probability distribution. This is a probability distribution. In a probability distribution, you have one column that is whole numbers and one column that's probabilities. This is method 3. And again, if we ask this question, you're like, I don't know. Put a star next to it, and we'll come back and we'll study this so that on test day you're like, oh yeah, I remember which method to go off of. This is method 3, which says stat calculators custom. Stat calculators custom. We need to select our shelters and our probabilities. Which one do I select for the values? The number of shelters or the probability? One of them's values, one of them's weights. Yeah, so the values are your X values, okay? The weights are your probabilities. So your values are your whole numbers. I have a bunch of whole numbers. So that's what I want in my values. I want number of animal shelters. My weights are going to be probabilities. And then I'll hit compute and I'll get my mean and my standard deviation, 2.092. Standard deviation 1.813. All right. There's my mean and my standard deviation. Okay. Interpret the mean and standard deviation in the context of the situation. So we expect a county in Michigan to have 2.092 animal shelters. Animal shelters. Ah, my goodness. Yeah, or take 1.813 animal shelters. So on average, counties in Michigan have a little more than 2 animal shelters. Okay. If a random Michigan county is selected, what is the probability that it has less than 3 animal shelters? So I need to add, so here's 3. So I need to add up the ones less than that. So this one, this one, this one. Do I add this one too or not? Am I adding up 0, 1, and 2 or 0, 1, 2, and 3? So Mike says not 3. Yeah. Less than 3 means 0, 1, and 2. Apparently there's some counties that have 0 animal shelters. It's probably like up in the UP maybe. So add up these 3 numbers. If this had said at most 3, then that would be 3 or less. But yeah, so add those up. Tell me what you get. Zero point 748. All right. If a random county is selected, what is the probability that it does not have 8 animal shelters? Apparently, there's counties that have 8 animal shelters. That's crazy. So you can either add up all of these or you can do 1 minus probability that it does have 8 animal shelters. Who wants to make a guess what county that is? Has 8 animal shelters. What's your guess, Cindy? I'm guessing Oakland County. Oakland County is huge and it's like suburb of Detroit, so it's like all city. There's a ton of people there. No guesses. Question number 5. The age. Detroit has a lot. Yeah. There's a couple different counties in Detroit. Uh, Wayne. Yeah, could be Wayne. The age of a deer hunter in Michigan is normally distributed with a mean of 45 years and a standard deviation of 14 years. Find the 3 missing values. Show a work, give 3 decimal places. Okay, so we need to find A1, A3, and X2. At the moment, we can only find one of them. Which one can I find right now? Which one can I find first? Yeah, I agree with you, Gabby. We can find A1 right now. Every Z value has a corresponding probability that goes with it. We can't necessarily find this one yet because we don't have these 2 numbers. But we can find A1 first. I want to start with A1. So to find A1, what do I need to do? So these 3 numbers add up to 100%, add up to 1. I don't know A3 yet, so I can't find it that way yet. I can't do 1 minus. So what I need to do is I need to use StatCrunch because this is a normal curve. So if I know that X is here, I can find that corresponding probability. But what do I click on in StatCrunch? So what page do I need to look at, or what buttons do I need to click in StatCrunch in order to find A1? Mike says stat calculator is normal. Yes, that's what I want. I want stat calculator is normal, which is on page 257. Page 257. So if I have a z-score, I can do this. If I have probability, I can find a z-score. I'm not doing any of that. I'm starting with this one down here. I have the no, nope, it's not that one. I have number 3. I have the X value. I want to find the probability. So this is number 3 first to find A1. So number 3, I have an X value. So I need to do stat calculators normal. Stat calculators. There it is. Now I'm not switching to between because right now I'm just looking at this and this is less than, okay? So I need to leave it as standard. Now if I have z-scores, I leave my mean as 0 and my standard deviation is 1, but I don't. I have x's, so they give me a mean of 45.3 and they have a standard deviation of 14.8. I'm going to put in my x is 14.265, and I'm going to leave it as less than and hit compute, and it's going to give me the area of that shaded red region there is 0.018. Okay, so that was stat calculator's normal. Leave it on standard, put in my mean and standard deviation, put in my x value, and I get what A1 is. Now that I have A1, I can find either A3 or X2. Which one can I find next? I can find A3 because these three numbers add up to 1. So can someone find A3 for me? Making you guys do all the work tonight. I'm sorry. Yep. So Gabby says if you do 1 minus this and minus this, oh, we got different numbers. Let's see. So if I do 1 minus 0.018 minus 0.671, we get 0.311. Okay. Right, got it. There we go. So next, now that's this shaded area here. I can find this X by doing page 257. Now I have an area. I need to find an X. So for this, to find this, I'm using number 4 steps. Okay. So this was number 3 on page 257. This one was just 1 minus A1 minus A2. Use right in calculator. All right. So I'm still on stat calculators normal. And I'm looking at standard, same mean, same standard deviation. But now I have the area is 311, but that's not it. That's on the wrong side because I need to flip this to greater than. Yes? So that's still not what I want. 311. There we go. 52. Thank you, Mike. 52.59. Ooh, 3 decimal places. 597. Okay. All right. Um, provide an interpretation. Oh, yeah, it's been a minute since we've done that. Yeah. So, I mean, yeah, it's been a while. We've been talking about math since what, January? It's we've been talking about maths for 3 months now. So yeah, so some of this stuff like we've, if you don't remember it, that's okay. Like that's one of the reasons why we're doing the sample final because refresh your. Oh yeah, that's right. Because right now everybody's very focused on hypothesis testing and confidence intervals. That's what we've been talking about in April. And you're like, okay, I know how to do that. So yeah. Another reason why it's a good idea to uh try the blank sample final exam. Okay. And if you get stuck on it, you can go back and remind yourself, right? Okay. Yeah, this was chapter 7. So this is still after the midterm, but yeah. Provide an interpretation of X1 and A1 using proportion. So there were two interpretations. One was proportion, one was for probability. Uh, so one of them went 1% of blah 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 is less than 14. The other one was if a random thing was chosen, then the probability that it's less than 14 is 0.018. So which one was the proportion? Which was it the random if you select a random one, or is it just you write out this as a percent? Like says percent. Yeah. So 1.8% of what were we even talking about here? The age of a deer hunter in Michigan. 1.8% of deer hunters in Michigan are less than 14.265 years old. Yeah, you can be You can be less than, you can be 14 to hunt deer in Michigan. Um, can you be, what's the age for bow hunting? Because it doesn't say, this doesn't say rifle. I know for rifle you have to be 14. Yeah. So 1% of deer hunters in Michigan are a little less than uh, 14 in a couple months. All right, we're gonna do one more page and we'll call it a night. Okay. Page 609. The following figures, uh, yeah, so okay, so Jalen's got a question for us about this one. Um, so this one is not in the exam notes packet, the interpretation here. But we did talk about two different ways of interpreting when you have proportions like this. One was using proportion, which we just did. So you write out the proportion as a percent. The percent of your data is less than, and then you write out what the X value is. Yeah, we wrote it in the notes. Yep. Um, the other way is for by writing it by probability, which is if a random deer hunter in Michigan was selected, the probability that they are less than 14 years old is 0.018. Okay, so those would be good ones to write on your 8.5 by 11 piece of paper if you want it in front of us. Yeah. Cindy had you write it on the bottom of what page did she ever write it on? Page 257. Okay. Yeah. So still page 257, but yeah, you had to write it out. And if you're not sure on that one, so Cindy and Elaine will be covering more of the sample final on Monday, but on Wednesday next week, they're not going to, we're going to be done with the sample final. They're going to be using their time to make sure you're ready to go. Make sure you've got everything written down that you need. So this would be a good one to make sure you have written down. If you're, yeah, ask them questions on Wednesday if you weren't sure on that one. So put a star next to it, right? Put a star next to the ones that you need to come back and revisit. Following figures show three sampling distributions of sample means randomly sampled from a population which had a standard deviation of 18.2. Sampling distributions, all drawn on the same scale, are based on sample sizes of 2, 4, and 10. Which one is A? Is it 2, 4, or 10? If that says 10. Agree, disagree? Gabby says 10. Yeah. Yep. A bigger sample size is going to lead to a smaller spread. Yep. B, is this 2 or 4? If that says 2, everybody agree or not? Yeah, you guys got it. Yep. Very spread out, right? And then this one will be the 4. Find the standard error of the sample distribution with the largest spread. The largest spread is B, so I'm going to be doing it based off of this one. So what was the formula for standard error? SEX bar was what? What's the formula? What's the formula? Or where can I find it? Or is this a stat crunch? Do I take this in stat? So what do I do? Something divided by something. I like that answer, Gabby. That is well done. So yeah. I'll put the divide. Yep, you're right about that. It is something divided by something. So page 259 has it in there. I wrote it at the bottom of my page 259, but I had to write it. So if you didn't write it, then you don't have it there. But what is the formula? Can somebody tell me what it is? Yeah, it says it is the standard deviation divided by the square root of the sample size. Yes, that is the formula for standard error. So, and if you weren't sure, if you know, I asked you where do I find that formula, and you're like, oh, I don't know, I'm putting a star there. Come back and study that. Okay, that's fine. Because yeah, today's not testing. We're going over this because it's been a while since we've covered this stuff, so we need a refresher. So standard deviation, they said, was 18.2. We are looking at the B1, which had a sample size of 2. So in my calculator, I get 18.2 divided by SQRT 2. 12.87. And what are the units? Because normally when we list out a standard deviation or a mean, there are units, right? Probability does not have units. We said that before. Probability is just a probability. You can write it as a percent if you move the decimal twice. Um, this one would have units if this was a story problem. This is one of those rare cases where in this class we are not doing a story problem. We're doing a quote unquote math problem. So there's no units here because I don't know if I'm talking about dollars or cars or you know, my measuring the effectiveness of my vaccine. I have no idea. This is just we're just talking about distribution, so there's no units. So all right. Now we're doing a story problem. Scientists want to determine if a birth control pill triggers weight loss or gain. 15 monkeys in a lab were given a banana flavored birth control pill every day. Hey, we have to, I don't know why we have to know it's a banana flavored one. All right. Okay. Banana flavored birth control pill. All right. How come humans can't get that? Banana flavored birth control pill. It seems unfair. 8 months while 17 monkeys in the same lab were given a banana flavored placebo. Okay. Um, it was found that the monkeys on birth control actually lost weight over the time frame compared to the other group. All right. Is this an observational or designed observational study or designed experiment? So yeah, this is a designed experiment. We chose who's getting what. Okay. An observational study is where you can't decide who's in which group. Okay. Can't. And here we can. Okay. All right, the response variable is banana flavoring, weight loss or gain, placebo, or birth control. Yeah, yeah, that and Crystal, I agree. It's the weight loss or gain. That is the response variable. Good. The control group is monkeys given birth control, monkeys who gained weight, monkeys given placebo, or monkeys who lost weight. Yep. Mike and Gabby, I agree. It is the placebo. Yep. The control group is the group that getting the placebo. The placebo doesn't do anything, right? The monkeys getting the birth control is the experiment group. Anytime that you are trying to test something, it's important to talk about what is the control group going to get. Okay. What are we doing with the control group? Because if I just, let's say that I'm testing a new vaccine, okay, and I inject a bunch of, I get 100 people, 100 random people. I do my random sample, and I inject all 100 with the vaccine. And of those 100 people, uh, let's say that two of them end up getting sick. That means that I have a 98% effectiveness on my vaccine. Only 2 people got sick, so a 2% sickness rate. Is my vaccine good or not? I don't know. I don't have anyone to compare that to. I need to be able to compare to a group of people who didn't get any medicine, the control group, because if the control group gets sick, if this is a sickness that doesn't happen very often and they only get sick 1 out of 100 times, then that means that 99% of the time your normal immune system is able to fight it off. So my vaccine actually made it easier to get that sickness. Okay. So you have to have a control group to compare to. Uh, what is 100 people didn't get it and same number got sick? So Mike, do you mean that so you mean that if you have the control group, let's say the control group has uh, you know, 2% sickness rate and the vaccine group also has a 2% sickness rate, then that tells me that my vaccine didn't do anything. My
Right.
vaccine is just as good as a
'Cause, I mean,
placebo.
there's nothing compared to, that was the answer. There was nothing to, because what if you had the same results for 100 people that didn't have it?
Oh, um, so you mean like
So if you
so
said
still
100
comparing,
people got the vaccine, 2 people got
yep,
sick. So
yes.
what happens if you didn't give 100 people a vaccine and you gave them, let's say, a placebo, but
Yep.
still 2 people got sick? You
So that
wouldn't,
tells me that the vaccine didn't do anything. The
yeah,
vaccine was just as good as a placebo, so the vaccine is worthless, right? Does it make sense?
yeah,
So, yeah, when you take a vaccine, when you get a vaccine, you would expect that the rate that you're going to get sick has gone down, right? I'm not I don't like shots. I don't like needles. I'm not getting a shot unless it's going to actually like keep me healthy. Yeah. So, all right. Oh, and I almost missed the last question here. How much weight the monkeys gained or lost over the course of the 8 months is qualitative, discrete, or continuous? Um, so can you lose like 5.5 pounds? Can you lose a decimal? Yes, you can. So that is continuous. All right. Hopefully that
I, I
explanation made sense, Mike.
I said
Go
I
ahead,
said
Kevin.
I said discreet because I was reading a paragraph while you were talking about the
Mm.
other thing, and they didn't say how much they lost, so that's why I said discreet.
Yeah, we don't know how much they lost, but what they're going to do is they're going to give some monkeys, the banana flavored birth control, and then a different group is going to get the placebo, and they're going to weigh those two groups of monkeys and see if the birth control group lost any weight. Okay. Does that make sense? So yeah, so they're gonna weigh each monkey and they're gonna record like maybe this one went up, maybe this one went down, but on average, did they go up or down? Now, why do we need a control group in that case? Can't I just say, well, weigh the monkeys before you give them the pill and after you give them the pill and see if they lost weight? Well, the control group lets me know like, did they lose weight because uh you know they're stressed. Maybe if I had to move these monkeys from a different facility to do this experiment, then maybe those monkeys are stressed out because of that move, and so they might lose weight because of that. Or maybe, there's something happened with their food or water. But if I have a control group and that control group lost weight, and the birth control group lost more weight, then I can say, okay, when I compare these two numbers, this one's down way, way more. So, anyway, that's as far as we're going to go tonight. If you have questions on anything, let me know. But as I mentioned before, take the time that you would normally, spend on your lecture notes, go through the rest of the sample final. Oh, there's the tortoise. The Anyway, I didn't get Cindy gets to cover that on Monday. So try the rest of the questions, and if you get stuck on anything, we will cover those next week.
Joe, the full-time faculty of the math department went to the Galapagos. Maybe
Okay.
two
Is that
years
why?
ago, I think. Yeah.
I did know that, but I was just curious why. So there's a picture of them, but I guess
I
maybe
think
this
Alana
might have been a
actually,
picture Alana took it. Yeah,
you're
Alana might
right.
have taken that picture.
Alana did take it.
I don't know. Okay. I thought maybe they were like the students had to like look at the picture and do something with it. So, okay. All right. Well, have a good night, everyone.